This is SpaceTime, Series 28, Episode 139, for broadcast on the 26th of November 2025. Coming up on SpaceTime, our solar system found moving through space much faster than expected, organic molecules discovered erupting from Saturn's moon Enceladus, and Sentinel-6B, a new satellite launched to study Earth's oceans. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has discovered that our solar system is moving through the universe at least 3 times faster than previously thought. The findings, reported in the journal Physical Review Letters, reveals a significant deviation from the standard model of cosmology. The study's lead author, Lucas Bohm from Bielefeld University, says how fast and in which direction our solar system is moving through the cosmos seems like a simple question. And it's an important one because it's a key test of science's understanding of the standard model of cosmology. But Bohm's analysis shows our solar system is actually moving more than 3 times faster than current models are predicting. This result clearly contradicts expectations based on standard cosmology and forces scientists to reconsider their previous assumptions. To determine the motion of our solar system, the authors analysed the distribution of radio galaxies. These are distant galaxies that emit especially strong radio waves at very long wavelengths. Because radio waves can penetrate dust and gas that obscure visible light, radio telescopes can observe galaxies invisible to optical observatories. Now, as our solar system moves through the universe, this motion produces a subtle headwind, and so slightly more radio galaxies appear in the direction of travel. Now, the difference is tiny, and it can only be detected using extremely sensitive measurements. So, using data from LOFAR, the Low Frequency Array Telescope, a Europe-wide radio telescope network, combined with data from 2 additional radio observatories, the authors were able to make an especially precise count of these radio galaxies for the first time. They applied a new statistical method that accounts for the fact that many radio galaxies consist of multiple components. And this improved analysis yielded larger, but also more realistic measurement uncertainties. Despite this, the combination of data from all these radio telescopes revealed a deviation exceeding 5 sigma. Now, that's a statistically very strong signal considered in science as evidence of a significant result. The measurements show an anisotropy or dipole in the distribution of radio galaxies that's 3.7 times stronger than what the standard model of the universe predicts. This model describes the origin and evolution of the cosmos since the Big Bang 13.8 billion years ago, and it assumes a largely uniform distribution of matter. The study's co-author, Dominic Schwartz, also from Bielefeld, says if the solar system is indeed moving this fast, scientists need to question fundamental assumptions about the large-scale structure of the universe. Alternatively, the distribution of radio galaxies itself may be less uniform than previously thought. But in either case, current models are being put to the test. The new results also confirm earlier observations, in which researchers studied quasars, the extremely bright centres of active supermassive black holes at the heart of distant galaxies. These gravity monsters consume matter, in the process emitting enormous amounts of energy, which can be seen across the other side of the universe as quasars. And the same unusual effect appeared in the infrared data, suggesting that it's not a measurement error, but a genuine feature of our universe. This study highlights how new observational methods can fundamentally reshape our understanding of the cosmos, and also how much there still remains to be discovered in the universe. This is SpaceTime. Still to come, organic molecules discovered erupting from the Saturnian ice moon Enceladus, and a new satellite, Sentinel-6B, launched to study Earth's oceans. All that and more still to come on SpaceTime. Scientists have detected more organic molecules erupting into space from the Saturnian ice moon Enceladus. This latest report in the journal Nature Astronomy claims a new analysis of data from NASA's Cassini mission has found evidence of previously undetected organic compounds in plumes of ice particles ejected from the global subsurface ocean that lies underneath the frozen Enceladus ice shell. The authors found not only molecules they had previously identified, but also new ones that are laying a potential path to both chemical and biochemical activity. The ice grains studied were collected just 21 kilometres above the frozen world's surface. It marks the first time that scientists have observed this level of organic diversity in fresh particles ejected from the Moon's South Pole tiger stripes. The findings signal an important step towards confirming active organic chemistry below the Moon's surface. This is the kind of chemical activity that could support compounds important to biological processes and in fact are essential components for life on Earth. Besides increasing the diversity of detected organics, the work adds a new layer to earlier findings by analysing particles that the Cassini spacecraft collected when it flew directly through a plume, the next best thing to diving directly into the Moon's ocean. Scientists had previously detected organics in ice grains that were years old and potentially altered by the intense radiation environment of space surrounding them. But these new compounds were just minutes old, literally fresh from the ocean below Enceladus' surface. Scientists already knew from previous Cassini data mining that nitrogen and oxygen-bearing organic compounds were present in particles from Saturn's E-ring. That's a faint wide outer band around the planet fed by the icy material spewing out from Enceladus' plumes. But this new research analysed ice grains from a moon plume itself, in other words, grains found closest to their subsurface origin. One of the study's authors, Frank Potsberg from the Berlin Free University, says the newly found molecules discovered in the freshly ejected material prove that complex organic molecules Cassini detected in the E-ring are not just a product of long exposure to space, but are readily available in Enceladus' ocean. The data was collected and sent to Earth back in 2008 when the ice particles impacted Cassini's Cosmic Dust Analyzer instrument. Besides being directly sourced from a geyser, the ice grains had another big thing going for them. They'd already been smashed to smithereens as they slammed into the instrument during the spacecraft's fast flyby, travelling at some 18 kilometres per second relative to the Moon. Now, the energy of that impact vaporised the ice grains and ionised a substantial fraction of them. And it was those ions that were then analysed by the instrument's mass spectrometer, which examined their chemical makeup. The newly detected compounds include aliphatic and cyclic ester and ester families, some with double bonds in their molecular structures. Together with the already confirmed aromatic, nitrogen and oxygen-bearing compounds, these newly found molecules can form the building blocks to support chemical reactions and processes that could have led to more complex organic chemistry, the kind that's of interest to astrobiology, and the kind which narrows the focus of where scientists need to search for signs of life in our solar system. This is SpaceTime. Still to come, a new satellite launched to study Earth's oceans, and later in the science report, a new study warns that kids with ADHD, autism or intellectual disabilities also have a significantly higher risk of death. All that and more still to come on SpaceTime. A new spacecraft designed to study Earth's oceans has been successfully launched into orbit. The joint NASA-European Space Agency Sentinel-6B satellite will extend a decades-long legacy of global sea level measurements that are helping to forecast weather, protecting coastal communities. The 1,190-kilogram probe, which is about the size of a pickup truck, was launched from Space Complex 4E at the Vandenberg Space Force Base in California aboard a SpaceX Falcon 9 rocket. The Sentinel-6B is part of Europe's Copernicus missions. It'll build on the legacy made by the earlier Sentinel-6A, marking sea level measurements, providing ocean and atmospheric data, and improving hurricane forecasts in order to help protect infrastructure and benefit commercial activities such as shipping. Sea levels vary from place to place, and the new satellite will provide accurate measurements at both local and global scales. Sentinel-6B will eventually take over from Sentinel-6A, which was launched back in 2020. As with its predecessor, the Sentinel-6B satellite will also provide key information about wind speeds, wave heights, as well as atmospheric temperature and humidity. Because water expands as its temperature increases, scientists are able to tell which parts of the ocean are warmer than others based on where the sea surface height is greater. The spacecraft will fly about 30 seconds behind Sentinel-6A, which carries identical science instruments. And once the mission finishes cross-calibrating the data collected by the two spacecraft, Sentinel-6A will move into a different orbit, and Sentinel-6B will take over its predecessor's role as the official reference satellite orbiting the Earth 13 times a day, some 1,336 kilometres above the surface. From this high-altitude perch, the satellite's instruments will measure some 90% of the Earth's oceans, all the way down to just fractions of a centimetre. This report from NASA TV.
Sentinel-6B is this really exciting high-tech satellite mission where we're measuring the height of the ocean from space. If we think about shipping, national security, fisheries, all of these depend on this information.
The ocean is very dynamic, it changes all the time. Having a measurement really is important towards understanding what's happening with the ocean, both in real time, but also in terms of forecasting.
We're in the business of trying to avoid emergencies, not just respond to them after the fact.
Sentinel-6 is a unique project. So it consists of two satellites built as twins, and the first one was launched, Sentinel-6 Mike Freilich, in 2020. The second one was built in parallel. We literally have hundreds, if not thousands of people working to build these programs together.
So Sentinel-6 Micro Freilich has been looking at the Earth, sea level around the globe, and now Sentinel-6B is going to take over. We've been tracking changes to sea level using satellites since 1992, so it's been more than 30 years now.
The way the Sentinel-6B measures is it sends a radar signal down to the surface of the ocean and measures how long it takes that signal to get back to the satellite. And from that, we can really get a very accurate measurement of how sea levels are changing locally and on a global scale, down to about a 1-inch accuracy.
Very dangerous Hurricane Milton rapidly approaching the west coast of the Florida Peninsula with multiple life-threatening hazards.
In 2024, Hurricane Milton intensified very rapidly, and Sentinel-6 Micro Freilich data were able to help us forecast this intensification.
Better predictions allow people to get out of the way before the storm hits. It allows them to take measures to protect their homes and their businesses. It allows emergency crews time to set up. All of these things are going to save lives.
That's the goal, is really to have data that's available within hours of the observations.
Sea level measurements are really critical to a number of different industries. So if you think about the packages that show up at your home, the expectation is that they arrive on time and arrive quickly. And Sentinel-6B can provide us the information we need to understand how to move things as quickly as possible from one part of the Earth to the other. So from a national security perspective, the U.S. military has installations all across the globe in coastal areas. Understanding the change in water level is really critical to preparedness.
With fishing, that data is used to understand where the fish are, how healthy they are, how they can be sustained, and how they can be managed better.
Sentinel-6B carries on this legacy of measuring sea level in a very consistent and very accurate manner.
Sentinel-6B will really propel us into the next decade and continue that sustained, highly accurate observation.
And understanding how water is moving in the open ocean, how it's moving close to the coast, that's really important information for us to protect our way of life.
And in that report from NASA TV, we heard from JPL Sentinel-B project manager Prag Vase, JPL Sentinel-6B deputy project scientist Silverine Fournier, JPL Sentinel-6B research scientist Ben Hamilton, and NOAA oceanographer Deirdre Byrne. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research looking at almost 900,000 New Zealand children has found that those with a neurodevelopmental condition such as ADHD, autism or intellectual disability also had a significantly higher death rate than neurotypical kids. A report in the Journal of the American Medical Association looked at children born between 1995 and 2009 and then followed their outcomes until 2019. They found the risk of early death was consistently higher for females, and it varied by condition, ranging from a doubled risk for kids with ADHD to more than an 8-fold risk increase for specific learning and motor disorders. A new study has found a clear link between stress and the likelihood of disease in koala populations along Australia's Pacific coast. The findings, reported in the Journal of General Virology, examined colonies of the iconic marsupials in southeast Queensland and on the New South Wales north coast. The scientists from the University of Queensland reached their conclusions by measuring and tracking levels of koala retrovirus in groups of both captive and wild koalas. A new study has shown that some 13% of young people in the United States are now using artificial intelligence to get mental health advice. A report in the Journal of the American Medical Association surveyed more than 1,000 people between the ages of 18 and 21, and they found even higher rates among those over 21, with 22.2% using AI for this purpose. They also found that some 65.5% of these users engaged at least monthly, with 92.7% finding the advice helpful. The use of AI for mental health advice reflects the low cost, immediacy, and perceived privacy of AI-based advice. But the findings raise some serious concerns, as many may need far more clinical help than what they're getting. And there are also concerns about the quality of the mental health advice which the AI models can provide. Well, the big tech news in the past week has been that airlines are now starting to impose strict new limits on carrying battery packs onto planes. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
In China and in Hong Kong, battery banks that were in the overhead luggage that people brought on board caught fire. And so there was this weird smell, and then there was this fire, and suddenly the overhead locker above people's heads was catching a blaze. No easy way to put this out. So what's happening is that on Cathay Pacific flights, for example, you're not allowed to have battery banks in the overhead locker. You've got to have them with you in the luggage that is under the plane seat or it's in the pocket, and you cannot be using them or charging them while in flight. You must use the charging port that's in the seat. And so same sort of thing has happened in Australia. Virgin, Jetstar and Qantas have all said, look, you can't have more than 2 power banks. They cannot be in the overhead locker. They must be with you. You cannot charge them. You cannot use them. You must use the in-seat power. And people have complained, well, half the time the in-seat power doesn't work. The limit is 100 watt-hours, which is 27,000 milliamp hours, which is the biggest battery bank you can take on the plane. And you can actually buy batteries that are more powerful than that. And when I've been overseas, they've actually had a close look at my battery to see what the rating was, to see if it was able to be taken on a plane. So the days of you taking multiple battery banks and putting in your overhead luggage are over. This is because the lithium-ion batteries, once they get damaged, they have this runaway thermal effect. You cannot just use water to put it out. It just keeps burning. We will eventually get around this problem because there are battery technologies that don't have this runaway thermal effect. But part of the problem is that a lot of batteries, they don't have quite the same standards. But I was in China just recently, and the Chinese have really clamped down on this. There is a battery standard that they must adhere to, but that doesn't prevent all fires. And even if you buy a well-known brand name, these things happen even to the top brands. So this is a warning. If you've got more than 2 power banks, don't take them on the plane with you. Don't put it in your luggage. And the sooner we get to better battery technology, the better.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.